Hello everyone and welcome to our today's class. It is our third lesson on the topic rectilinear propagation and reflection at plane surfaces. So as always, let me start by giving you the quote of the day, which states that before you complain of not having the latest fashions of shoes, take some time to think of those who have no legs. That is, before you complain of not having the latest fashion of shoes, take some time to think of those who have no legs. So today we'll be discussing about reflection of light. Now, bodies like the sun, stars, lamps and fires can be seen because they are luminous. That is, they produce their own light. However, non-luminous objects are seen when light from one of these sources, like the sun, bounces off their surface into our eyes. This bouncing back of light is what we are calling what? Reflection. Now remember that the amount of light energy reflected by a body depends on the nature of the surface of the body, that is, whether the surface is either smooth or rough. So the smoother the surface, the greater the fraction of light reflected from the body, and the brighter the body appears to our eyes. Now, what is reflection? What is reflection? So reflection actually refers to the act of bouncing light through the same angle after hitting a given surface, such as a plane mirror. We are saying that reflection is the act of bouncing light through the same angle after hitting a given surface, such as a plane mirror. Now there are two types of reflection. One is what we call the regular, or sometimes we call it the specular reflection. Then two, we have what we call the irregular or diffuse. The irregular or diffuse reflection. Now let's discuss these two types of reflection. So let's start with the regular or specular reflection. So in this type of reflection, this whereby light from a given source hits a smooth surface, a highly polished smooth surface, such that the rays emerge parallel to each other, that is after reflection on the surface. However, in diffuse or irregular reflection, this whereby the rays of light from a given source, they hit a rough surface, such that after the rays have hit the rough surface, they are reflected in different directions, or they are reflected in irregular directions. That's why it is sometimes we call it irregular reflection or diffuse reflection. So the main difference is that the surfaces where the rays are hitting. So for regular, this whereby we use a smooth or a highly polished surface, whereby the rays after hitting the surface, they emerge parallel to each other, or they move exactly in the same direction. Whereas for diffuse or irregular reflection, this whereby the rays hit a rough surface, hence they emerge in opposite or in different directions. So this is what we call irregular or diffuse type of what? Reflection. We also look at some given definition of some terms which are used in reflection of light. So this is an incident ray. So an incident ray, actually it means it is just a ray emanating from a given source of light, then it hits our smooth surface here, then it is reflected. So this is what we call an incident ray. Incident means it is coming from somewhere, then it is hitting that surface before it is being reflected. So the term incident ray simply means, so the incident ray is the ray that travels from the source of the reflecting surface. So this is what we are calling the incident ray. It is a ray that travels from the source of the reflecting surface. Then we have what we call the angle of incidence. So students should know the difference between incident and incidence. So when we talk of incidence, we mean the angle. Then when we talk of the incident, we mean the ray. So the angle of incidence, this is what we are calling the angle of incidence, is denoted by small I, as shown in this diagram. So this is what we are calling the angle of incidence. Now, what is the angle of incidence? So the angle of incidence This is the angle between the incident ray and the normal. This is what we are calling the normal. So the angle between this incident ray and this normal, that is this angle here, this is what we are calling the angle of incidence. The angle of incidence. Then we also have what we are calling the normal here. So a normal, this is the line drawn perpendicular at the point where the incident ray strikes the reflecting surface. This is what we are calling the normal. So it is important for students to know that the word normal means perpendicular. Therefore, a normal will always meet the reflecting surface at 90 degrees. So we are saying that the angle from the normal up to this surface is actually 90 degrees. Also, the angle from the normal to this reflecting surface, it is always 90 degrees or perpendicular. So a normal, this is the line that we are calling the normal. So a normal is the line drawn perpendicular at the point where the incident ray strikes the reflecting surface, that is at this particular point. Then we also have what we are calling this ray here, what we are calling the reflected ray. Now what is a reflected ray? So the reflected ray is the ray that bounces from the reflecting surface. Is a ray that bounces from the reflecting surface. That is, after this incident ray hits the reflecting surface at the point of incidence, that is where you have the normal, it is reflected. So reflected ray is the ray that bounces from the reflecting surface. This is what we are calling the reflected ray. So you can also look at the arrow. It is showing that the ray is actually coming from the reflecting surface. Then this arrow shows that this is an incident ray that is coming on the surface before reflection. Then we have what we call the angle of reflection. The angle of reflection. So sometimes we denote it by small r. Now what is the angle of reflection? So the angle of reflection, this is the angle between the reflected ray and the normal. So this is our normal, then this is the reflected ray. So the angle between the normal and the reflected ray, that is what we are calling the angle of reflection. The angle of reflection. So from there we can actually look at the laws of reflection. Now there are two basic laws of reflection. So you can be asked to state the two laws of reflection. So they can ask you to state the first law of reflection or even the second law of reflection. So the first law of reflection states that the angle of incidence, that is small I, equals to the angle of reflection, that is small r. So the first law of reflection simply states that the angle of incidence is equal to the angle of reflection. The angle of incidence is equals to the angle of reflection. So that means that if we measure the angle of incidence here, then we find it maybe to be something like 20 degrees. It means also the angle of reflection will also be 20 degrees. So if you are asked to state the first law of reflection, you simply say that the first law of reflection states that the angle of incidence is equals to the angle of reflection. The angle of incidence is equals to the angle of reflection. So students, sometimes they confuse. You find a student writing the angle of incident is equals to the angle of reflection. That is not true. So if we are talking of an angle, it must be incidence and not incident. So the law of reflection states that the first law of reflection states that the angle of incidence is equals to the angle of reflection. Then the second law of reflection simply states that the incident ray, the reflected ray and the normal at the point of incidence all lie on the same plane. That is, the incident ray, the reflected ray and the normal at the point of incidence all lie on the same plane. So this is what simply the law says, that the incident ray, that is this ray that is emanating from the source, the incident ray, the reflected ray, that is this incident ray and the reflected ray, this is our reflected ray, and the normal, this is our normal, at the point of incidence. The point of incidence, this is what we are calling the point of incidence. So the point of incidence is just a point whereby all these three rays meet. That is the incident ray, is meets with the normal and also meets with the reflected ray. So this particular point here is what we are calling the point of incidence. So the normal of the point of incidence all lie on the same plane. So a plane is just a flat surface. So this is our flat mirror or our flat surface. So you can see this incident ray, the normal, and the reflected ray, they lie on the same plane. That is, they lie on the same side of the plane. So remember, this mirror has the upper side and also the lower side. So when we say they lie on the same plane, it simply means that they are all on the upper plane, or they are on the upper side. Remember, they can also be on the lower side, but they all have to be on the same side of the plane, or on the same plane, or on the same side of the mirror. So because the incident ray is on the upper side of the mirror, the normal is on the upper side of the mirror, then the reflected ray is on the upper side of the mirror, it means they lie on the same plane. They are on the same plane, that is, on the same side of the reflecting surface. So we are saying that the second law of reflection states that the incident ray, it says that the incident ray, comma, the reflected ray and the normal at the point of incidence, this point of incidence, all lie on the same plane. That is, the incident ray, comma, the reflected ray and the normal at the point of incidence all lie on the same plane. They all lie on the same plane. So those are the two laws of reflection. So we look at an example involving rotation of mirrors at an angle. We look at an example involving rotation of mirrors at an angle. So the question actually reads, the example actually reads that a plane mirror lying with its surface up makes an angle of 10 degrees with the horizontal, full stop. A ray of light shines down vertically on the mirror as shown. What is the angle of incidence? What is the angle of incidence? So remember, we have just defined that, or we have just said that the angle of incidence is the angle between the incident ray and the normal. So if this is our normal, then this is our incident ray. So remember, to identify which one is the incident ray and which one is the reflected ray, you just look at the direction of the rays. So here the direction means the arrow actually points downward, meaning the ray is emanating from somewhere here. So a ray which is emanating from a source, that is a ray that travels from a source to the reflecting surface. That is what we are calling the incident ray. So this is our incident ray because the arrow is actually pointing on the reflecting surface. Then this is our normal. So remember, the normal is always perpendicular to the reflecting surface. So the angle between the normal and the incident ray, that is what we are calling the angle of incidence, which is denoted by small I. So in this question, we are required to state what is the angle of incidence. We are required to state the value of the angle of incidence. So if you look at this particular question keenly, actually the angle separating the horizontal surface and the plane mirror is 10 degrees Celsius. Now remember that the incident ray is, we have been told that the incident ray is always perpendicular to the horizontal. So this particular ray meets the horizontal. This is our horizontal surface. It meets the horizontal perpendicularly, that is at 90 degrees. Therefore, a normal drawn to the inclined mirror through the point of incidence makes an angle I with the incident ray. So if we draw a normal here, actually the angle between the normal and the incident ray, this is what we are calling the angle of incidence that we have actually been asked to find. Then so a normal drawn to the inclined mirror through the point of incidence makes an angle I with the incident ray. Now, using the property of vertically opposite angles, the angle, that is this angle. So if I was to extend this one downward, then also the incident ray downwards, you will actually see that this angle 10 is vertically opposite to angle I. So I is our angle of incidence. So we are saying that the angle of incidence will actually be 10 degrees, which is equals to this angle here. The reason being the I and the 10 degrees here will be vertically opposite angles. They are vertically opposite angles. Now remember, vertically opposite angles are always equal. So we are saying that the angle of incidence in this case will be 10 degrees Celsius. Then part B, we are told that what angle will the reflected ray make with A, the vertical? What angle will the reflected ray make with the vertical? Now remember, this is our reflected ray. So the angle between the reflected ray, the angle made by between the reflected ray and the normal is what we are calling the angle of reflection. That is denoted by small r, the angle of reflection. Now remember, the first law of reflection actually told us that the angle of incidence will always be equal to the angle of reflection. So if the angle of incidence, we have found it as 10 degrees Celsius, it means also the angle of reflection will be 10 degrees Celsius. But the question wants us to find what angle will the reflected ray make with the vertical. What angle will the reflected ray make with the vertical? So because the angle of incidence is equal to the angle of reflection, which is 10 degrees Celsius, therefore it means that, remember, we are told that the ray, so a ray of light shines down vertically on the mirror. So it means the ray of light is actually vertical. It is shining vertically. So if you are we are asked to find the angle that the reflected ray makes with the vertical, it means they actually want the angle between the incident ray, because the incident ray is actually vertical, it is meeting the mirror vertically. So they want the angle between this incident ray and actually the reflected ray. That is the angle that the reflected ray makes with the vertical, because the incident ray is actually vertical. So in short, this is the angle that they want. That is r plus I. So the angle that it makes with the vertical will be the angle between this reflected ray and the vertical. That is because the incident ray is actually vertical. So this angle here will be r plus r. So remember, incident ray was 10 degrees Celsius, but from the first law of reflection, the angle of incidence is equal to the angle of reflection. So it means that if this was 10 degrees, this is also 10 degrees. Therefore, the angle that the reflected ray makes with the vertical will be 10 plus 10, which is actually 20 degrees, which is 20 degrees. Then Roman 2, we also asked to find the horizontal. That is, what angle will the reflected ray make with the horizontal. Now, which is the horizontal in this case? Now remember that the horizontal that they are talking of in this case is actually this line down here. This is what we are calling the horizontal. So this is our reflected ray. So they want the angle between the reflected ray and the horizontal. So if I was to extend this reflected ray downwards, if suppose I extended it up to meet the horizontal. Now remember, on the horizontal we already have an angle of 10. Then this is the vertical, this is the normal, meaning the angle between the normal and this mirror is actually 90 degrees. Remember, the normal is always perpendicular to the reflecting surface. So that means that if I extend this particular line downwards, then I also extend the normal downwards, then the angle that they want me to find, that is the angle between the reflected ray and the horizontal, this angle downwards. Now to find that angle, it means actually, because from the normal up to the horizontal surface, that angle is 90 degrees. It means to find the angle between the reflected ray and the horizontal will actually be, to find that, I will actually take the whole of that is from the normal downwards, which is 90 degrees. Then I subtract angle r, then I also subtract the 10 degrees Celsius, because that is the angle between the horizontal and the reflecting surface. So if I want to find the angle between reflected ray and the horizontal surface, I will take 90 degrees. Remember, 90 degrees is coming from the angle between the normal and the reflecting surface. So it will actually be 90 degrees minus r, then also I subtract the 10 degrees Celsius. So that will be, remember, r, that is the angle of reflection, was equals to the angle of incidence, which was 10 degrees Celsius. So to find the angle between the reflected surface, between the reflected ray and the horizontal, will actually be 90 degrees minus 10 plus 10. So 10 plus 10, that is the 10 of the reflected ray, and the 10 here we actually get 20 degrees. Then 90 degrees minus 20 degrees, you will get this angle, that is from the reflected ray up to the horizontal, the reflected ray up to the horizontal. So that angle will be 90 degrees minus 20, which actually comes to 70 degrees, which comes to 70 degrees. So we can also look at another example, which is now involving rotation of plane mirrors. So the question reads that the figure below shows a ray incident at an angle of 25 degrees at position 1. So this is our position 1. Then the mirror is turned through 6 degrees to position 2. So this mirror is turned upwards in this direction to position 2. So we are being asked that through what angle is the reflected ray rotated? Through what angle is the reflected ray rotated? So if this is our incident ray, remember the reflected ray will come somewhere here in this direction through the same angle of 25 degrees, because the angle of incidence will always be equal to the angle of reflection. So it means if I'm turning this by 6 degrees, that is the angle here from 1 to 2 is 6 degrees. So we have the 6 degrees here. Then also remember, when I turn this one upwards, on this case this one actually moves downwards by the same angle of 6 degrees. So that means if I want to find the angle through which the reflected ray will be rotated, it will actually be the 6 degrees, that is from here upward here, then also the 6 degrees from downward towards this direction. So the angle through which the reflected ray is turned will be the 6 degrees turned upward here, then plus the 6 degrees that the turning of upward actually causes this to be turned downward. So remember, when one moves to position 2, actually the one here, the one that was here, it also moves downwards by the same angle of 6 degrees. So the total angle of rotation will actually be the 6 degrees here plus the 6 degrees here, which actually gives 12 degrees. So through what angle is the reflected ray rotated? So the reflected ray is rotated through an angle of 12 degrees, or through an angle of 12 degrees. So the 12 degrees is actually coming from the 6 degrees here and the 6 degrees downward here. Then lastly, we look at formation of images by plane mirrors. We look at formation of images by plane mirrors. Now, how are images formed by plane mirrors? Now, plane mirrors form images by regular reflection. So regular reflection means that after reflection, actually the rays will move either parallel or in the same direction, that is after reflection. So plane mirrors form images by regular reflection. So the no parallax method is used to locate images in plane mirrors. So remember, parallax means that we actually, this method is reducing the errors due to parallax. So to locate images in plane mirrors, we use the no or the non parallax method. We use it to locate the images in a plane mirror. Now here is our object, then this is our image in this case. So if an object is placed in front of a plane mirror at some distance as shown in this diagram, actually the rays of light, remember we said that for a person to see something, the rays of light must move from the object to the eyes of that particular person. So the rays of light will always originate or emanate from the object. So that tells you that the object has to be illuminated or has to be in a region where we have light, because if it is in darkness, it will have no light to reflect to your eyes. That's why you cannot see an object in a dark area, whereas a person in a bright area, is able to see an object in a bright area. Why? Because the object has the light to reflect to the person's eye. So this is how it takes place. So the rays of light emanate from the object, then they hit the reflecting surface, then they are reflected in this particular direction. So the image, for a plane mirror, the image will always be formed behind the mirror. Remember, all images are formed behind the mirror. They are virtual images. Now, what are virtual images? Virtual simply means these are images that are not formed by actual intersection of the real rays. If you have a mirror, then you look your face. You look at your face through the mirror. You will see the face appearing behind the mirror. That is, the face appears to be behind the mirror. That is, it is imaginary. Because if you go behind the mirror, the truth is you will not find that face, but it appears as if it is behind the mirror. That's why it is imaginary. So if it is imaginary, it means it is not being formed by actual intersection of the real rays. So it is imaginary, and therefore we call it virtual. It is virtual, and it appears to be behind the mirror. If you try to estimate the distance between the object and the plane mirror, and the distance between the plane mirror and the object formed, you will realize that those distances will exactly be the same. You realize that the distances will exactly be the same. So you can be in an exam, you can be drawn an object here, then a plane mirror, then someone asks you to sketch the rays of light, how the image will be formed, how the image will be formed. So you always remember that the image, the rays of light always originate or emanate from the object. Then when they meet the plane surface, they are reflected, but you extend them. So in this, because this is behind the mirror, it means these rays are virtual, or they are imaginary. That's why we are using dotted lines. Even the image here, I've used dotted lines because it is virtual or imaginary. So the rays on the side facing the plane mirror have to be in full lines, showing that the rays are real, also the object is real, but the image formed is virtual, or it is behind the mirror. So you use dotted lines as I've shown in this particular diagram, although we look at the characteristics of images formed by plane mirrors. Now, if you reflect a word, for example, law, this is how it will appear. Actually, the first letter here comes last, then the second letter comes second, then the last letter here comes first. So these are characteristics that we call lateral inversion. So the image formed is laterally inverted. What do we mean by the word lateral inversion? So this is whereby this is the sideways turning effect, where left appears right. That is, if you observe your face through a plane mirror, you will see that the right ear or the right eye in the plane mirror appears to be on the left side. So that means the image is laterally. Lateral means horizontal. That is, it is inverted horizontally. It is inverted horizontal, such that what was coming first actually comes last, and what was coming last comes first. So try looking at the mirror. Just type any particular word, then face it on the mirror. You will actually see that it appears laterally inverted. So this effect, we call it lateral inversion. It is called lateral inversion. So lastly, we look at the characteristics of image formed by a plane mirror. What are the characteristics of the image formed by a plane mirror? Now we have three main characteristics of images formed by a plane mirror. Of course, you can see all of them here just by observation. So one is that the image is as far behind the mirror as the object is in front of the mirror. So that is the first characteristic or property of the image formed by a plane mirror. So this is what we mean, that the distance from the object to the mirror is the same as the distance from the mirror to the image. So the first characteristic is that the image formed is far behind the mirror as the object is in front of the mirror. Another way of saying the same point is that the image distance equals to the object distance measured from the mirror. That is, remember we said the object distance is the distance from the object to the reflecting mirror. Then the image distance is the distance of the image from the reflecting mirror or the reflecting surface. So the first property of or characteristics of image formed by a plane mirror is that the image distance, that is the object distance, the distance from the object to the mirror, is equal to the image distance, that is the distance from the mirror to the image. So the first characteristic is that you can say of the image formed by a plane mirror is that one, that the image is far behind the mirror as the object is in front of the mirror. We have said the same way. Another way of saying the same point is that the image distance is equals to the object distance from the mirror. So that is the first characteristic of image formed by a plane mirror, that the image distance equals the object distance from the mirror. Now the second characteristic of image formed by a plane mirror is that the image is the same size as the object, that the image is same size as the object. That is the height, the length, the width, and whichever. If you look at this lamp of mine, is the same, is approximately of the same dimensions with the image formed. So if this one had a height of 2 centimeter, I expect the image also to be have a height of 2 centimeter. If it had a width of maybe 5 centimeter, I expect the image also to be of 5 centimeter. So we are saying that the second characteristic of image formed by a plane mirror is that the image is the same size as the object. The image is the same size as the object. The image is of the same size as the object. Then the last characteristic of image formed by a plane mirror is that the image formed, the image is virtual, erect, and laterally inverted. The image is virtual, erect or upright, and laterally inverted. So let's discuss that point. So virtual, we have said that virtual simply means that the image is not formed by actual intersection of the real rays. Or sometimes we just say that virtual means image is not formed on the screen. The image is not formed on the screen. Or the image is not formed by actual intersection of the real rays. So that the image formed is virtual, erect, and laterally inverted. So erect means it is upright, as you can see here. So the first one, you have said that the image formed is virtual. So virtual in physics we denote it by dotted line. So you can see my image is actually dotted. Then the image is erect. Erect means it is upright. That is the object was facing upwards. The image is also facing what? Upwards. So it is erect or it is upright. Then the last one is that the image is laterally inverted. The image is laterally inverted. So we have already said that lateral inversion means what was coming first comes last, then what was coming last comes first, as it is appeared here in the law. So this is what we are calling the lateral inversion. Lateral inversion. So maybe just to give you a recap, we have said that we have 3 properties or characteristics of images formed by a plane mirror. One is that the image is as far behind the mirror as the object is in front of the mirror. We have said another way of saying the same point is that the image distance equals to the object distance. Then the second characteristic of image formed by a plane mirror is that the image is the same size as the object. The image is the same size as the object. Then the last characteristic of image formed by a plane mirror is that the image is virtual, erect, and laterally inverted. The image is virtual, erect, and laterally inverted. So we've come to the end of our class today, but we need to discuss the quote of our day. So the quote of the day simply said that before you complain of not having the latest fashion of shoes, take some time to think of those who have no legs. So the quote simply means that we should be appreciative with the small things we already have in life. That is, we should not just be people of complaining. Appreciate the small that you have first before you look for the next one. Yeah. And before you ask for the latest fashion of goggles and specs, think of those who don't have eyes. Yeah. So you should also be thinking of others. And lastly, remember that you need to celebrate the small things in life, because sometimes later you will come to realize that what you thought were the small things in the past, those were actually the big things. That is, celebrate the small things in life, because sometimes later you will realize that what you thought were the small things were actually the big things. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.